So let us calculate the integral of 2x plus secant x times tangent x dx. What is this integral? We are basically reviewing what we learned before. This can be written as the integral of 2x dx plus the integral of secant x tangent x dx, which in turn is equal to the integral of 2x following the integral of u to the n du, which is u to power n plus 1 divided by n plus 1 plus c, can be written as x squared, and the integral of secant tangent, as you remember, is equal to. So remember that if you have secant tangent, secant of x is 1 over cosine of x. What is the derivative of secant? To take the derivative of secant, you're basically taking the derivative of 1 over cosine of x, which is applying the quotient rule. You have the derivative of 1, which is 0, times cosine x, which is 0, minus the derivative of cosine, which is negative sine. So you end up with positive sine, divided by, you take the denominator and raise it to the second power, cosine squared of x, which in turn can be written as sine x divided by cosine x times 1 over cosine x, or tangent x times secant x. So let me keep the order for you. Times secant of x. So what's the meaning of that? It means that wherever you see the integral of secant tangent, it is actually secant x. So this integral, the integral of secant tangent, is equal to secant of x plus constant of integration. So whenever you forget about the formula, you can also take the derivative and remember the derivative of secant, which is secant tangent. Or in terms, the integral of tangent secant or secant tangent is equal to the integral of secant itself. Our next question, let us work on some absolute value problems. Suppose I ask you to calculate the definite integral -1 to 2 of absolute value of x minus x squared dx, right? So how do we calculate this definite integral? What does it look like? When you have absolute value function, you try to separate this into smaller pieces, all right? From algebra, remember that if you have x minus x squared, this is basically a polynomial of degree 2, which is a quadratic. If you set it equal to 0 and factor out x, you get 1 minus x equal to 0. It means that this polynomial passes through x-axis at 0 and 1. You can also visualize this. So move it up a little bit. So in xy plane, when x is equal to 0, you have a 0. When x is equal to 1, you have a 0 as well, okay? So if you plug in other values, like -1, what do you get? You get -1, -1, or you get -2 on the right. So it means that the graph opens downward like this. Or you can look at the leading coefficient, which is negative. So this is the behavior of your graph. It's not precise, but it gives us some idea of what's going on here. But why it is important for us? Take a look. Our definite integral starts from -1. So from -1 to 0, my graph is below x-axis. My y value is negative. Now, from 0 to 1, my graph is above x-axis. Right, so let me just erase this part to avoid any confusion. Between 0 to 1, my graph is above x-axis and it is positive. But take a look at it again. From 1 to positive infinity, as you can see, my graph again is below x-axis. My y is negative. But why it is important? Having an absolute value, it shows that, well, on which interval you get a positive value, on which interval you get a negative value. So it means that you can divide this up into 3 pieces, right? So this is my 0, this is my 1. This can be written as the integral -1 to 0. Between -1 and 0, my y is negative. So this absolute value is written as minus x squared dx. Plus, between 0 and 1, I have a positive y value. It means that I get x minus x squared back. And from 1 to 2, the y is negative again. Remember the definition of absolute value. You have a negative sign in front of x minus x squared dx. So you have 3 integrals to calculate. One integral, -1 to 0, which is this piece here for this part of y value. Then you have 0 to 1. Then you have 1 to 2. 3 pieces of integral. Okay, it's not that difficult to calculate these integrals. You already know how to deal with these. So this is the definite integral, -1 to 0 of x squared minus x dx, which can be written as, let me write the answer here, a third x cubed minus a half x squared, -1 to 0. If you plug in 0, everything disappears. So the only thing we need is the negative sign. And please note that you have a negative in front of it as well. So you get -1 third minus a half, which gives us -5 divided by 6, or 5/6. This is one calculation, one piece calculation, which is this piece, -1 to 0. Then you have 0 to 1. For 0 to 1, the calculation is a half x squared minus a third x cubed between 0 to 1. Again, if you plug in 0, everything disappears. You only need 1. So you have a half minus a third, which is 1/6. And finally, the last piece is this piece here, which is the integral of x squared minus x dx between 1 to 2. This is equal to a third x cubed minus a half x squared. But now we have to plug in 2. We have to plug in 1 and do the calculation because no value disappears. You have 8 divided by 3 minus 4/2 minus a third minus a half So let's see, what do we get? Can we simplify anything? You have a third minus 2. And here you have plus 1/6, right? Very good. So if you take common denominator between these two, let's see if we can simplify this further. You get 16 plus 1. So you have 17 divided by 6 minus 2, or 5/6. Okay, now you need to add all of these together. You have 5/6 plus 1/6 plus 5/6. Okay, you have 11 divided by 6 is this definite integral, or you can say that, hey, the area below the curve while x is bounded between -1 and 2.